Hi, in this recording we're going to take a look at the second one-a-day problem, which asks you to consider a box with a square base with rectangular sides and with no top. So first thing we'll do is we'll assign some variable names to the lengths of the different sides. Since it's a square base, if we call one side W, well, we have no choice about the other sides. They all have to be W. And, okay, so these would all be W. And we want to know the height also of the box. So let me give that a name. We'll just call that H. And of course, all these lines on the outside, those are actually supposed to be also of length W. Alright, so first thing we might consider is the volume, and they tell us in the problem that the volume is going to be 80 cubic inches. Now there's a nice formula for the volume of a box, which is namely the area of the base times the height of the box. And the area of the base is simply W squared, since it's a square. So we know that the volume is W squared times H, and that's supposed to equal 80. Well, quickly we see we can solve for H here. And if we do that, dividing by W squared gives us H equal 80 over W squared. One useful bit of this representation is we can pretty easily see what's going to happen as far as the domain goes. So, well, looking at the top one, we know W is not going to be 0. Otherwise, the volume couldn't possibly be 80. You certainly don't want negative W's, so W is going to be something which is positive. But looking at the second thing, if we make W really, really large, it's going to make H really, really tiny, but not 0. And that's all we really need. H can be as small as we like, so W can be as large as we like. So in fact, the domain here is going to be all W between 0 and infinity, where we don't include infinity just by rule, it's not a number, and we don't include 0 since then we wouldn't really have a box. Now, we neglect the thickness of this material and just assume that it's completely made with the same amount of material as its surface area. So what's the surface area? Well, the surface area is the area of this bottom bit, and it's also the area of these 4 rectangles that go around the box. Now, the bottom bit is easy. We know the area is W squared. And each one of these rectangles has base W and height H. So each one of them is W times H. And since there's 4 of them, the surface area is going to be the W squared from the bottom plus 4 of these WH's. Alright, so there's our formula for the surface area. But remember up here, we had a formula for the height. It's 80 over W squared. So I can replace H in my formula for surface area. And then I'm left with just W's. Alright, I want to simplify this a little bit. Alright, so multiplying through, I get that the surface area is completely determined by W squared plus 320 over W. And of course we're interested in the surface area because even though the volume is fixed, by changing the dimensions, namely by changing W, I can change the surface area and hence maybe use less material. So in the next video, I'll show you how to graph S and then try to find the minimum surface area.